Chapter 1. Values, Types, and Operators. Below the surface of the machine, the program moves. Without effort, it expands and contracts. In great harmony, electrons scatter and regroup. The forms on the monitor are but ripples on the water. The essence stays invisibly below. Master Yuan Ma, The Book of Programming. Inside the computer's world, there is only data. You can read data, modify data, create new data. But that which isn't data cannot be mentioned. All this data is stored as long sequences of bits and is thus fundamentally alike. Bits are any kind of two-valued things, usually described as zeros and ones. Inside the computer, they take forms such as a high or low electrical charge, a strong or weak signal, or a shiny or dull spot on the surface of a CD. Any piece of discrete information can be reduced to a sequence of zeros and ones and thus represented in bits. For example, we can express the number 13 in bits. It works the same way as a decimal number, but instead of 10 different digits, you have only 2, and the weight of each increases by a factor of 2 from right to left. Here are the bits that make up the number 13, with the weights of the digits shown below them. So 00001101. The very right-hand one, its value is 1. The third from the right one has the value of 4. And the fourth from the right one has the value of 8. So 8 plus 4 is 12 plus 1 is 13. So that is the binary number 1101. So that's the binary number 00001101. Its non-zero digits stand for 8, 4, and 1 and add up to 13. Values. Imagine a sea of bits, an ocean of them. A typical modern computer has more than 30 billion bits in its volatile data storage, working memory. Non-volatile storage, the hard disk or equivalent, tends to have yet a few orders of magnitude more. To be able to work with such quantities of bits without getting lost, we must separate them into chunks that represent pieces of information. In a JavaScript environment, those chunks are called values. Though all values are made of bits, they play different roles. Every value has a type that determines its role. Some values are numbers, some values are pieces of text, some values are functions, and so on. To create a value, you must merely invoke its name. This is convenient. You don't have to gather building material for your values or pay for them. You just call for one, and whoosh, you have it. They are not really created from thin air, of course. Every value has to be stored somewhere. And if you want to use a gigantic amount of them at the same time, you might run out of memory. Fortunately, this is a problem only if you need them all simultaneously. As soon as you no longer use a value, it will dissipate, leaving behind its bits to be recycled as building material for the next generation of values. This chapter introduces the atomic elements of JavaScript programs. That is, the simple value types and the operators that can act on such values. Numbers. Values of the number type are, unsurprisingly, numeric values. In a JavaScript program, they are written as follows. 13. Use that in a program and it will cause the bit pattern for the number 13 to come into existence inside the computer's memory. JavaScript uses a fixed number of bits, 64 of them, to store a single number value. There are only so many patterns you can make with 64 bits, which means that the number of different numbers that can be represented is limited. With n decimal digits, you can represent 10 to the n numbers. Similarly, given 64 binary digits, you can represent 2 to the 64 different numbers, which is about 18 quintillion, and 18 with 18 zeros after it. That's a lot. Computer memory used to be much smaller, and people tended to use groups of 8 or 16 bits to represent their numbers. It was easy to accidentally overflow such small numbers, to end up with a number that did not fit into the given number of bits. Today, even computers that fit in your pocket have plenty of memory, so you are free to use 64-bit chunks, and you need to worry about overflow only when dealing with truly astronomical numbers. Not all whole numbers less than 18 quintillion fit in a JavaScript number, though. Those bits also store negative numbers, so one bit indicates the sign of the number. A bigger issue is that non-whole numbers must also be represented. To do this, some of the bits are used to store the position of the decimal point. The actual maximum whole number that can be stored is more in the range of 9 quadrillion, 15 zeros, which is still pleasantly huge. Fractional numbers are written by using a dot, 9.81. For very big or very small numbers, you may also use scientific notation by adding an e for exponent, followed by the exponent of the number. 2.998E8. That is 2.998 times 10 to the 8th, or 299,800,000. Calculations with whole numbers, also called integers, smaller than the aforementioned 9 quadrillion, are guaranteed to always be precise. Unfortunately, calculations with fractional numbers are generally not. Just as pi cannot be precisely expressed by a finite number of decimal digits, many numbers lose some precision when only 64 bits are available to store them. This is a shame, but it causes practical problems only in specific situations. The important thing is to be aware of it and treat fractional digital numbers as approximations, not as precise values. Arithmetic. The main thing to do with numbers is arithmetic. Arithmetic operations such as addition or multiplication take two number values and produce a new number from them. Here is what they look like in JavaScript. 100 plus 4 times 11. The plus and star symbol are called operators. The first stands for addition and the second stands for multiplication. Putting an operator between two values will apply it to those values and produce a new value. But does the example mean add 4 and 100 and multiply the result by 11? or is the multiplication done before the adding? As you might have guessed, the multiplication happens first. But as in mathematics, you can change this by wrapping the addition in parentheses, like parentheses 100 plus 4 times 11. For subtraction, there is the minus operator, and division can be done with the slash operator. When operators appear together without parentheses, the order in which they are applied is determined by the precedence of the operators. The example shows that multiplication comes before addition. The division operator has the same precedence as multiplication, likewise for addition and subtraction. When multiple operators with the same precedence appear next to each other, as in 1 minus 2 plus 1, they are applied left to right. Parentheses 1 minus 2 close parentheses plus 1. These rules of precedence are not something you should worry about. When in doubt, just add parentheses. There is one more arithmetic operator, which you might not immediately recognize. The percent symbol is used to represent the remainder operation. X percent y is the remainder of dividing x by y. For example, 314% 100 produces 14, because 100 goes into 300 three times, and the remainder is the 14, so the answer is 14. And 144% 12 gives 0. That's because 144 mod 12, 12 goes into 144 12 times, and there's no remainder. That's why it's 0. The percent symbol is modular arithmetic, which gives you the remainder on division. The remainder operator's precedence is the same as that of multiplication and division. You'll also often see this operator referred to as modulo. Special numbers. There are 3 special values in JavaScript that are considered numbers but don't behave like normal numbers. The first 2 are infinity and negative infinity, which represent the positive and negative infinities. Infinity minus 1 is still infinity, and so on. Don't put too much trust in infinity-based computation, though. It isn't mathematically sound, and it will quickly lead to the next special number, n, a, n. Capital N, little a, capital N. NaN stands for not a number, even though it is a value of the number type. You'll get this result when you, for example, try to calculate 0 divided by 0. Infinity minus infinity, or any number of other numeric operations that don't yield a meaningful result. Strings. The next basic data type is the string. Strings are used to represent text. They are written by enclosing their content in quotes. Down on the sea. Lie on the ocean. Float on the ocean. Each of those is placed in quotes. You can use single quotes. That's up here. Double quotes, that's here. Or backticks to mark strings. As long as the quotes at the start and the end of the string match. Almost anything can be put between quotes, and JavaScript will make a string value out of it. But a few characters are more difficult. You can imagine how putting quotes between quotes might be hard. New lines, the characters you get when you press Enter, can be included without escaping only when the string is quoted with backticks. To make it possible to include such characters in a string, the following notation is used. Whenever a backslash is found inside quoted text, it indicates that the character after it has a special meaning. This is called escaping the character. A quote that is preceded by a backslash will not end the string but be part of it. When an end character occurs after a backslash, it is interpreted as a new line. Similarly, a T after a backslash means a tab character. Take the following string. This is the first line, \n, and this is the second. The actual text contained in this is the first line, then go to the next line, and this is the second. That \n puts the text in a second line. There are, of course, \n. There are, of course, situations where you want a backslash in a string to be just a backslash, not a special code. If two backslashes follow each other, they will collapse together, and only one will be left in the resulting string value. This is how the string, a new line character, is written like, quote, \n, quote. Can be expressed, a new line character is written like \quote, then two backslashes n \quote dot quote. The first backslash allows you to put the quote in there without the computer thinking it's a string. Then the two backslashes are interpreted as one backslash next to the n. And then the next backslash lets that quote be put in there without the computer interpreting it for a string. Okay. Strings, too, have to be modeled as a series of bits to be able to exist inside the computer. The way JavaScript does this is based on the Unicode standard. This standard assigns a number to virtually every character you would ever need, including characters from Greek, Arabic, Japanese, Armenian, and so on. If we have a number for every character, a string can be described by a sequence of numbers. And that's what JavaScript does. But there's a complication. JavaScript's representation uses 16 bits per string element, which can describe up to 2 to the 16 different characters. But Unicode defines more characters than that, about twice as many at this point. So some characters, such as many emoji, take up 2 character positions in JavaScript strings. We'll come back to this in Chapter 5. Strings cannot be divided, multiplied, or subtracted, but the plus operator can be used on them. It does not add, but it concatenates. It glues 2 strings together. The following line will produce the string, quote, concatenate, close quotes. So you put con in quotes, plus cat in quotes, plus e in quotes, plus nate in quotes, and together that will be combined to make concatenate in quotes. String values have a number of associated functions, methods that can be used to perform other operations on them. I'll say more about these in Chapter 4. Strings written with single or double quotes behave very much the same. The only difference is in which type of quote you need to escape inside of them. Backtick quoted strings, usually called template literals, can do a few more tricks. Apart from being able to span lines, they can also embed other values. Half of 100 is $bracket 100 divided by 2, close brackets. When you write something inside $, open and close brackets, in a template literal, its result will be computed, converted to a string, and included at that position. The example produces half of 100 is 50, where in this case, according to that, the $sign makes it a string. So 50 is treated as a string.